Alright guys, welcome back to another Unreal Engine 4 tutorial. In this tutorial we're going to go over what I've been showing off the last few days with the whole marker on the ground, trying to recreate the ground pound move from Halo 5. So just to show you the end result that we're going to get from this tutorial, we're just going to be able to have the ability to show the marker, have it display on surfaces, and being able to leave it in place once you let go. So this is not the full functionality just yet of the ground pound move from Halo 5. Obviously this is just the marker portion. So there's going to be more to come after this, but I wanted to create a tutorial just to show you how to get this kind of functionality. So with that in mind, we're going to do everything from scratch, including setting up the material, creating our character, things like that. So let's go ahead and let's get started. So I'm going to be using this just as playground level that I had built for the objective markers. I just like the environment, which is a fun playground to be in. So this is going to be the build that I'm going to be using. It's 4.8, but it should work in 4.9. That's where I built the original version of the ground pound marker, so you shouldn't have any problems there. So to start, we're going to actually go into Photoshop. I already have the textures created, so I'm going to open them up real quick to show you what they are. Okay. So the small marker is just a same version of the large marker here. So they're pretty similar. The small marker has the same central marker, but also has these lines. I use the ruler tool to kind of map everything out here for this one, and for this one as well, just so they're central, they're in the middle of everything. So this is what they are. Without any background, you can't really see it too well, but this is what they look like. Not much into detail. All I did was use the circle tool, erase certain portions of it just to make the marker. And then I of course made the alpha channel for each one. So that's what they look like. Pretty simple. I'm not going to make these from scratch, just because you can do whatever you want in terms of these markers. But that's what they look like with their alpha channel. So just make sure you have an alpha for your marker. Once you have those, you're actually ready to import them into the actual Unreal editor here. So I'm going to go into Content Browser. I'm going to go into Content. I'm going to make a new folder. I'm just going to call this Ground Pound Tutorial, just so I can recognize it. And then I'm going to make a new folder, and I'm going to call it Textures. So get this build out of the way. So now that we have our textures, let's right-click, let's hit Import, and just navigate to wherever you put your textures. And the reason why I made two versions of it, the large and the small, is because the way the marker works in Halo 5, first you see the large marker, and then after a short period of time, once it kind of locks in what you're about to do, the smaller marker comes in as well. So I want the ability to hide and unhide the smaller marker from the large one. So I wanted to keep them two different entities. And also make sure when you are making textures that they are a power of 2. So, 256 by 256, 1024 by 1024, whatever you want, just make sure it's a power of 2. And also, I make sure I export them as a targa with 32-bit, because they have alphas. So now that we have our two markers here, what we can do now is make our material. And it's going to be pretty simple, simple material as well. So first, let me make a folder called Materials. Then we're going to right-click, do Material, we'll call this Mat, underscore ground pound, underscore marker. Save and double-click on it to open it up. And we'll need both texture samples. So we'll get the large first. And when you have a texture selected in your content browser, you can just hold down the T key and left-click, and it'll give you that texture sample. We'll do the same thing for the small. And what we're going to do, first and foremost here, is we're going to grab onto the main material function here, and we're going to change its blend mode from opaque to mask. And the shading model, instead of it being default lit, we're going to set it to unlit. And now what we're going to need to do, we're going to use a combination of emissive color and opacity mask to actually make the material work. So I want to control what color the marker is. That's why I make my texture white, just so it's easily multiplied by colors to change the color. So I want to have a vector parameter to control color here. And I'm going to call this marker color. And I'm going to set its default value to 1111, just so it's white. And now what I can do, let's first work with the opacity here. And when I work with any kind of markers or HUD elements, I make sure to preview them on a plane. So make sure you choose the plane option in the material preview mesh. Now what we can do is, add both the alpha masks from our two textures, add them together, and put it into opacity mask. And just for the time being, so you can see, we can put the marker color into the emissive property. So now you can see them together. Obviously, it's not rotating, no movement or anything, but that's just the preview of what we can have happen here with these two textures. But what I want to have happen, for the color at least, I want to be able to multiply that by a value to make this as bright or as dim as possible. So what I'll need here is a scalar parameter, and that just allows you to create a scalar, name whatever you want, and reference it in a blueprint if you so choose. We'll call it emissive color. I'm going to set its default value to 3. And now what I'm going to do is take a multiply function, and you can hold down the M key and left click to get a multiply. Just multiply the top color here with the emissive color property, and then throw that into emissive color. Now you can see it's really bright, and if I mess with the material, the scalar value here, change from 3 to 10, it'll be really bright. If I change it back to 0, it's going to be completely dark. If I do like 0.2, it's dim. 3 for right now is fine. And of course, you can take the marker color, change it to whatever color you want. But I'm going to leave it at white for default. And then what I want to do as well, like I mentioned earlier, is I want to control which one is showing at one time. So either the large marker or the small marker with the lines coming out from it. So to control that, we'll need another scalar parameter. I'm going to name this smaller marker opacity. I'm going to leave its default value at 0 for right now. And then we're going to take another multiply function. We're going to multiply the alpha mask of our smaller marker, multiply it by our opacity. And then we're going to take that result and put it into the add. So now we just see the large marker. But if I were to change the marker opacity value from 0 to 1, we'll see both, which is, of course, exactly what we want to have happen. We'll be able to control that really easily. So now the last thing we need to do is actually get the ability to rotate. So what we'll need is something called a rotator. And the rotator just basically rotates the UVs so that it looks like it's spinning. So we'll plug them into both. And I'm going to change the value from 0.25 to negative 0.8. And the value I'm changing is the speed parameter in the rotator. And I'm going to just copy and paste that into the UVs of our other texture sample. And as you can see, they're working, which is great. But one thing you may notice is overlapping. And by that, what I mean is, if I were to go into my texture, let's see where they're at. So sometimes by default, the x-axis tiling method and the y-axis tiling method is set to wrap, and that's the default setting for those. So what can happen is the tiling can cause things to overlap and look really weird. So if you see that happen, all you really gotta do is change the from wrap to clamp. That's what I had to do originally. It probably just saved it to my target, so that's why it's not happening here. But if you see weird overlapping when you're rotating, just change the x-axis tiling method and the y-axis tiling method from wrap to clamp. And you'll find it in the extra menu for the texture. When you open up your texture in the texture editor, you'll see a little drop down there for showing advanced in the texture group. That's where you'll find these parameters. So if that happens, changing that to clamp will fix your problem. But now everything looks good. The material's done. So we can again just hit save and exit out of that. And what I want to make sure I have as well is a blueprint strictly for the actual marker here. So what we'll do, we'll create a new folder. We'll call it blueprints. And then we'll right click, do a blueprint class, and choose actor. And I'll call this BP marker. And now what we'll do, we'll open that up. We'll add a component, and it'll just be a, well, we'll need to add a plane mesh. So what I'll do, I'll go into shapes. I'll select shape plane, and then in my blueprint, I'll add component, add static mesh. I'm going to call SM marker. And then I'll grab my material and just replace the material. And there we go. And then I want to make this a little bigger, so I'll just scale it to 3. Just looks nice and big. And then what else I'm going to do here in this blueprint, just for future purposes here, is in the construction script, I'm going to make a material instance reference so that I can reference those scalar and vector parameters in this blueprint. So I'm going to get a reference to our SM marker, pull from it a create dynamic material instance function, plug that into the construction script. Now it needs to know which material we're talking about, so we'll just make sure that our ground pound marker material is selected, and then we'll hit that arrow, and then I'll tell it to choose that material. And then we'll just pull from the return value, promote that to a variable, and I'll just call that marker material instance. And what we can notice too, because before I left the material, I set the opacity parameter for that smaller ring to the number 1. So that's why the smaller ring is showing right now. So what we can do is in our event graph, we can just set it to 0 in the actual material, but just to show you how the material instance works, we'll do it in the blueprint. What we'll do, we'll grab a reference to our marker material instance that we created, and we'll do a set scalar parameter value. Plug that in, and now we need to get the parameter name. So if we double click back into our material, the parameter name is smaller marker opacity. So we can just copy that name, paste it into the parameter name value, and leave its default value at 0. See, there won't be any change here unless we set this to the construction script, which we can do as well. So I can just copy that in here. So now if I compile this and go back into my viewport, we just have the large marker. So that's all set. Now in terms of other materials, I do have a glow material that I used. So if I go back into the original game here, if I right click, you'll see these two dome meshes with the material on it. So I'll show you how to make that as well. And it's pretty super simple too, how to do this one. So let's go back into our content browser and into our materials folder. We'll right click, do a new material. We'll call it mat underscore, call it Orb Glow. Click on that. And for this material, the main function, instead of it being opaque, we're going to set it to translucent. And we're going to use a function, a mathematical function called Fresnel. So let's get a Fresnel out here. And we're going to need two different types of parameters, a scalar and a vector again. So we'll do a vector first to control color. And I'll just call this Fresnel color. We'll make this white. And then we'll need a scalar parameter. And we'll call this Fresnel exponent. We're going to set its default value to 4. And now we're going to plug the Fresnel exponent into the exponent input of the Fresnel. And then we're going to use a multiply function to multiply the color and the end result of the Fresnel. So we're going to multiply those two together. And one's going into emissive color and the other one's going into opacity. And Fresnel basically gives you this kind of look. I'm not 100% sure on the math behind it, but it kind of gives you this glowy look and kind of brightens up the edges of your material. Depending how your material looks, like obviously on a plane it doesn't look right. On a cylinder it looks fine. On the orb or the sphere, that one looks best there. But that's how you make that material. It's pretty simple. So I'm just going to save that. Close out of my materials here. One last thing too is I used a dome static mesh that I created in 3ds Max. So I'm just going to import that in real quick. I'm going to call a new folder, call it meshes. I'm just going to right click, import new asset. I have a mesh called sm_dome. It's an FBX. Import all. And here's my dome. Nothing fancy. And I'm just going to apply that orb material that we just made to it. Now we got this glowy orb. So I'm going to save that. And then I'm going to grab it in our actual editor here in our content browser, select it. Now I'm going to add it to this blueprint so that they're there. So add static mesh, sm_dome, and I'll enter with a prefix of small. And now I'm going to scale it about 0.5 or so. Let me go into my construction script, set this value to 1 so I can see the actual smaller marker. And a scale of 0.5 works just fine. I just want to kind of border the smaller marker. And then I'm going to duplicate this one, give it a name sm_dome_large. I'm just going to scale this up by 1.5 should be it. Yeah. And then in its z-axis, I guess it's like 0.5 or maybe just 1. So that's how this one's going to look. And this is the end of the actual blueprint for the marker itself. The handling of it spawning and actually working, that's going to go in the actual character itself. But this is the blueprint itself. We're going to work way more with this later on once I get more going for the blueprint as a whole. But for now, this is all you need. So now what I'm going to do is in my blueprints here, I'm going to create my own character. And to do that, I'm just going to copy, and again for this, I'm using a first-person game type. So I'm going to just duplicate their first-person character blueprint. So right here under first-person BP, they have one called first-person character. I'm just going to drag this into the ground pound tutorial under blueprints, do a copy. I'm I'm going to rename it. You can rename it BP underscore, I'll call it Halo character, just because this is this is a blueprint that's using Halo as a reference. So we can open that up, and we have all the same functionality, same variables, same everything. But what else I like to do is make my own game type. So I'm going to right-click in my blueprints folder, go to blueprint class, do game mode. I'm going to call this BP underscore Halo underscore game mode. And I'm going to open up this game mode. And for default pawn class, I'm going to set that to BP underscore Halo character. And then in my actual map itself, under world settings, I'm going to override my game mode and set it to BP underscore Halo game mode. So now when I play, it plays the correct kind of game mode. Whereas before it was showing like the BP marker stuff with that other objective-based tutorial that I had up. Now with our own custom character and custom game mode, we don't see anything of that. We just see what we want to see. So with that done, we're actually now ready to add functionality so that we can start spawning the actual blueprint that we made for the marker, to make sure it shows up correctly and everything like that. So where I'm going to start is using the event tick event. So we'll type in event tick. And what we want to, how I want this to control right now is if you hold down the right mouse button, it spawns, it spawns what you want to spawn, the marker. So what I used to do that is I get our player controller. I use a function called isInputKeyDown, and I'll ask you which key. And that's where I'm going to choose right mouse button. And then it sends out a return value, a boolean. So we're going to cut that out as a branch. So if it's true, just to show you, we'll do a print string. If it's true, we'll have it print out right mouse button down as a string. Oops. Let's compile that and jump in and test. So right now I'm not holding it, but if I right click and I keep it held, it keeps printing. And then I let go, it eventually stops. So click, unclick. So we know that functionality is working. So we can get rid of this print string. We only need that for debugging. And now how we want this to work is we want to do a line trace because we don't want the person to do a marker anywhere they want in the environment. We definitely want to limit the distance. So we're going to do that by performing a line trace. So we can right click the line trace by channel. Connect that directly into the true. And now this is where we're going to do a little bit of math because we want to start and end point. So what we're going to first do is we're going to get a reference to our camera. So let's get a first person camera here. And this is a default variable that comes included with the first person blueprint. So again, reference to the camera, we're going to get the world location. And this world location is going to be our start point. Now the end point, what I want to have is about 1,500 units in front of us. So to do that, we need to first get the rotation of our camera so we know what's straight ahead. So we'll get the world rotation. And to know directly what's in front of us, we need to get the forward vector. So we're going to pull from the world rotation, get forward vector. And now this is where we multiply this vector by a float. And the float's going to be the actual distance that you want. So in this case, for me, it's 1,500. And we basically need to add this end result here, the multiplication of our 1,500 by our forward vector. We basically need to add that to the existing starting vector where our camera is located. Now this end result goes into the end of our line trace. And to kind of show you how this works, for the drug debug type, we'll do a persistent. So now if we play in our editor, we hold down right mouse button, we're seeing it getting drawn. So we know that's working too. So again, the math is just the first person camera. We get its world location. We set that location as our start point for our drawing of our line trace. And then for the end result, we get the world rotation of that camera, get its forward vector so we know what's forward, and then we multiply that by the distance that we want, and then we add that to the camera's initial world location and set that to the end. So now we know it's drawing from our start point in front of us to 1500 units ahead of us, no matter what the rotation is. So now what we need to do is determine whether or not we're hitting something. So this is what this return value is. So we're going to pull this return value from the line trace. I'm going to do a branch. And we can set up a new print string just so we can kind of show you it's working. And we'll type out something called hit. Now we can compile that. Let's save. And now I'm right clicking right now and nothing's happening because I'm not hitting anything. But if I move my camera here to this box and right click once, it gives me a hit a couple times just because of how the line trace is working. So right now it's hitting, still hitting, and then it's going to stop up here. Because I'm not hitting anything. I'm hitting again over here. So we know that this is working too, this condition. And something else we're going to need here is at this out hit, we're going to need to get its break hit result. We're going to need some of this information that's available here in this hit result. But what we're going to do first, from this true, we're going to create a sequence because we want two things to happen. One, we want to spawn our BP marker, and we only want to spawn it once. We don't want the blueprint to be spawned each time this is true. So what we're going to need is a function called a do once. We're going to put that into the first portion of the sequence. And to reset a do once, you need to plug something into this reset. And what I'm going to plug into this reset is the false when our right mouse button is down. So when our right mouse button is up, that's when we want to reset this. And then from here, this is where we can use a function called spawn actor from class. So we're going to plug the completed of this do once into the spawn actor from class. Right now it's set to none, so we need to set its class, and that's going to be the BP underscore marker. And then for the spawn transform, we're going to right click, and we're going to split its structural pin, because we want to separate the location, the rotation, and the scale all to their separate things here. For spawn transform scale, we're just going to set that to 3 in all axes, because that's something we know is going to stay consistent. But in terms of location and rotation, what we're going to need here is a couple different things. One is we're going to be creating a specific function. It's kind of a complicated function, but I'll show you how it works. So we're going to do add a new function. I'm going to call this set marker offset location. And I'm going to tell you why we're going to create this function right now. Because right now what will happen is, well, before I explain that, I'll set it up so we can have the actual actor spawn and set its rotation appropriately here. So to really do that, what I'm going to need is from this return value of our spawn actor, I'm going to grab our SM underscore marker. So get SM underscore marker. And something I'm actually remembering just now is in our marker blueprint, let's make sure that the dome small and the dome large, they're childs of the marker itself. So just make sure they're under that structure here. So all you have to do is click on it, drag it on top of the marker, just to make sure that the marker is the parent of those two domes. The reason why we're doing that is so the rotation given to the marker will also be given to its children, the small and large dome. So just make sure you do that before moving forward. And what we're going to do here, grabbing from this SM underscore marker, is grab it, do set world transform. And again, we're going to right click on the transform, split a structural pin, Set its new transform scale to 333. And what we're going to do for the second sequence, the then 1, is we're going to plug this into the set world transform that's down here. And now that that's set up, all we have to worry about now is the location of rotation that we're setting here. So the location is going to be the impact point that we're getting. So we're just going to drag that in to both new transform locations. And now for the rotation, this is where it doesn't get too funky, but just a little bit of math involved. We're going to grab the impact normal. We're going to make a rotation from its z. So make rot from z. Then we're going to get its up vector. And we're going to leave the up vector alone for right now. This is what we're going to use for our actual function that we're going to create in a couple of minutes. But all we really need to do is, from here, the return value of our make rotation from z, that can go into our rotation in both the spawn actor from class and from our spawn world transform here. So now if we play, we can hold down right click. We're kind of having a little bit of trouble here, and the reason why is I believe our first person character, the mesh that we're using, the mesh 2P here, this might have collision on it. So we're going to give it no collision for right now. Actually, I know the reason. Let's give this collision again. We're going to go into our blueprint marker. And then for the SM marker, we're just going to make sure that it has no collision. And the same thing goes for our two domes. Just set it to no collision here. So let's try that again. There we go. And now if we let go, the marker stays in place. But as you can see, we have Z fighting because it's a plane. And that's what the function we're going to be creating is going to do. It's going to create an offset so clipping doesn't exist. So here we see clipping on this surface. If we go over here, we may not see clipping on this surface, but we see clipping on that surface. So that's what the offset's going to do. It's to make sure that clipping doesn't happen. So what we need for the function itself, it's going to require this up vector that we pulled out, and it's also going to require the impact point. So let's go back into our function. To start, we're going to select our function here. We're going to add two inputs. Both of them are going to be the type of vector. First one I'm going to name is impact point. Second one I'm going to name up vector. And now for the return node, we're going to create a new parameter for that one as well. It's going to be a vector. We're going to call it output vector. And the result of the output vector, we're actually going to create a new variable for that. I'm going to call this offset marker location. I'm going to make this a type of vector. And then I'm just going to get this variable and set it to our output vector. And this is a variable we're going to be setting along the whole way within this function. So now what we can do is to start, we're going to disconnect these two, just so they're not connected by default. I'm going to move this guy away for a little bit. Now for impact point, first we're going to do a set. First we're going to set the impact point that we're going to get as our offset marker location. And to make more sense of this, we're going to go back into our event graph here. We're going to drag in our function. And the function is going to be plugged in directly to this then underscore, or the then one of our sequence here. I'm just going to plug that right in. And then this gets continued into our set world transform over here. And now we're going to plug in our up vector into the up vector input, and then the impact point as well is going to be plugged into this impact point. So now we can compile that. And obviously we're going to get a warning because this function is not complete. That's fine. But now our impact point is receiving the vector that gets from this break result of our line trace, and then we also get the up vector, which is good. And the up vector is going to give us a number, either a positive or negative 1 in each axis to let us know what's happening upon the impact. So what we're going to need to do, so from our up vector, we're going to break this result. And the way the numbers work, it gets a little weird. So what we're going to do is round these floats into integers. So we're going to round them to a whole number. We're going to do this for each direction. Now that we have these rounded numbers, what we can now do is do a comparison to see if this number is greater than or less than 0. Because again, the number we're going to get from our up vector, kind of just to show you what it does, is we're going to grab a print. We're going to plug this into the then, and then the up vector we're getting, we're going to plug that into the string. So it's going to print out a vector for us. It's going to give us a warning, but it's fine. So if I right click, as you can see here, right now we're getting a value of positive 1 in the z. But if we hit the ceiling, we're going to get a value of negative 0.983. Again, this is sloped, so that's why we're getting that number. So if I could find a normal surface, here we go. This one's going to give us negative 1. And then again, on the floor, it's positive 1. And same thing goes for the walls. So right here, we're getting a negative 1 in the y. Then on a wall facing this direction, we're going to get a positive 1 in the y. And then on this side, we're going to get a positive 1 in the x. But if I hit this wall, we get a negative 1 in the x. So that's what these numbers do. And that's the result that we're getting from this up vector. And the reason why we're rounding is so that we get whole numbers, so we don't have to worry about specific numbers at all. So to start, we'll get the return value of the x round. We'll do if it's greater than 0. And then we'll also grab it, see if it's less than 0. And then we'll copy and paste these guys here, connect in the round value for the y into these two. And then we'll copy and paste them one more time. We'll do it for the z. So now we have a bunch of comparisons. We have nothing from there. But now what we can do is a bunch of branches. So from the first one, basically saying, hey, is the rounded x value of our up vector greater than 0? Let's branch out and find out. So we'll do a branch. Now if this is true, we want to set up some logic. If it's false, we want to check the next question. Is it less than 0 for the x? Do a branch and find out. Connect false into this new branch. If this is false, then we want to move on to the y. So basically this is going to go into a kind of chronological order here. So we're just going to keep creating branches here, plugging in the false. Then the last one here. Now we have all of our conditions set up. And what we want to have happen here, if the last one is also false, we just want to set this to a normal impact point. So we're going to just plug this right back in. Because again, the offset marker location is being set to the default impact point by default. It's only when we get true values where we're going to change this variable here. So to kind of show you what I mean. So first, if our x value is greater than 0, so if it's a positive 1 in the x from this up vector, we want to add 5 to the x value of our offset location vector. So to do that, we're going to grab our offset marker location, do a get, grab its structural pin, and split it, so we get x, y, and z separate. What we're going to do, grabbing from the x, we're going to do a plus float, and we're going to add 5. And then now what we're going to do is make a vector. add the results here to the x, and then just pull the y and z from the default value into here. And then this end result, this return value vector, we're going to set that as our new offset marker location. So kind of organize this as best as you can. So now the true is going to get put into this set, and then this set is going to be put into our return node. So we just got to do that for each one of these. We just got to make a little bit of room. We're going to copy and paste this guy. But now this one is going to be less than or equal to, or less than 0. So what we want to do is add a -5 to this. Set this to true, and then plug this in. So we just kind of have to follow that order. So the next one, we're going to, instead of it being the x, I don't know what that one is. Get rid of that. So we're going to copy and paste this. But instead of it being the x affected, this one's going to be the y. So we're going to disconnect the y here, add 5 to it. Plug into the y, set it's true here, put into the return. Let's move the return to a more centralized location. So the next one's going to be less than 0 for the y. So we're just going to copy and paste that. Oops. We're going to copy that, paste it, set it to a -5. Set the true. Plug that end result to our return node. And then the last one is going to be our z. So we're going to copy and paste. This one was for the y, so we're going to disconnect that, plug the y directly in, and then disconnect the z, plug that into this addition of 5, plug that into the new make vector for z, plug in its true into that set, and then plug in the set to our return. And then we just got to do this one more time. Make it a -5, plug in the true, and then plug this into our return. And that's all we need to do. We can compile that, and then what we need to do is just get rid of this print string. The second portion, the then one of our sequence, it's plugged directly into this function. Right now we are getting an error, so let's just re-put it in our function. So let's plug that into the start. The impact point is going to be coming from our break result over here. Its impact, the up vector is going to come from the impact normal, the make rotation from Z, the up vector gets plugged into there. And now this output vector is getting plugged into both the transform location of our spawn actor from class and our new location transform for our set world transform here. And then last but not least, we just plug this into our set world transform. So we compile, no errors, we jump in, and we draw on the floor. And we are still seeing clipping. We're not seeing clipping here, which is good. So let's go back into our function here. And obviously this is the Z. So let's try switching these. We'll make this a -5 and a +5. Let's jump back in. Still not working. Let's make these higher values, maybe 10, -10. At least we're not seeing anywhere else. Just the Z. That's still clipping. Oh, no, never mind. So that's going into the Z, that's also going into the Z. Okay. So this one's going into that one. That one's there. And that one's there. Let's try that again. There we go. I had some things plugged into the wrong places, so we can change these values back to -5 and 5. File again. And now we see no more clipping. But what you'll see as well, kind of when you're moving along, you see this blur effect. If you want to get rid of that blur effect, you would just need to go into your, what's the name of that, post-processing volume. You just need to go into your post-process, go into details, go into the settings, go to motion blur, and just zero out all those values. So you have a value for amount, max, and per object size. Zero them out, and now there's no more blur. It's a nice, clean marker that's now showing up. And it gets the normals, and it doesn't appear until you're looking at distance. And we got everything working the way we want to. So just to do a quick recap, what we did is we created our two textures, the small marker, the large marker, and then the small marker. And whenever we see overlaps in the material, so if we go into our ground pound marker material, if you ever see weird overlaps happening when using the rotator, that's where you would go in to the texture itself and change the x-axis tiling method and the y-axis tiling method. From wrap, you would choose clamp. Mine doesn't need to have that because I already set it to clamp previously, and the Targa saved it that way. So when I imported it, it automatically did that for me. And then all we need to do to create this material is set up the rotators, and we set this to -0.8 for the speed for both of these rotators, and the center X and center Y are staying at their default values of 0.5, and we plug that into both UVs for the large and small. And now to control the color of the marker, we just created two parameters, a vector parameter called marker color, and that affects the color of the marker, and then a scalar parameter called emissive color. This one controls the actual power of the emissive color. We just multiply those together and put them into the emissive color input. And for the main function of this material, we set its blend mode to masked and its shading model to unlit. And then last but not least, to actually have the opacity working, we just first we have a scalar parameter for the smaller marker opacity, because we want to change whether or not that's showing up. So if we set that to 0, we only get the large marker. We set this to 1, we get both markers. So we multiply this value with the actual alpha mask of our smaller texture, and then we take that result, add it to the alpha mask of our larger texture, and then the result of that goes into our opacity mask. So that's how you make that material. Save any changes, and then we also created an Orb Glow Material, and what we did here is on the main material function, we changed its blend mode from opaque to translucent. We created two different types of parameters, again a vector parameter called Fresnel color to basically control the color of our circle here, and then a scalar parameter called Fresnel exponent just to control the power of our Fresnel here. And then we actually have a Fresnel function that we plug the exponent scalar parameter created into the exponent integer here, and then we multiplied that result by the color and put both of that results into the emissive color and then the opacity to get this result. And then from there, we created an actor blueprint for our marker itself. In here, we have the marker as a plane, and then the material onto it, and then two dome meshes that I created in 3ds Max with the Orb Glow Material on top of them. And then in the construction script, we created, from our SM marker, we created a dynamic material instance from our material, the ground pound material, and we set that return value as its own variable, so that we can do things like this, where we can set the scalar parameter value, tell it the name of the scalar parameter, and tell it the value. So right now it's set to 1, and that's why we see both large and small when we implement it. But if I were to change this to 0 and compile and play, we'll just see the large marker. And then from there, we created a brand new player, and how we did that is we just went into the first person blueprint and got their first person character and just created a duplicate of it so we can get the same functionality. So right now we have all the stick inputs, the mouse inputs, and everything. But it's here in the actual character that we set up the functionality to show up our marker. And to do that, we got our player controller, check to see if our right mouse button is down, and on event tick, we check that that boolean to see if it's down or not. If it is down, that's where we create a new line trace. And the line trace works that from our first person camera variable, we get its world location, that's our start. And then we also get our first person camera, we get its world rotation so we know which way it's looking. We get its forward vector so we can tell which direction it's forward at that point. And then we multiply that vector by the actual number of units forward that we want the maximum distance to be. And in this case I set it to 1500. And then from there we added that result to the world location of our first person camera, and that result is set to our end. And right now our draw debug type is set to persistent, but we can set that to none because we don't need to see the debug line anymore. We can just see this. And it's from here we get a return value to see if we are actually hitting something or not. If we are not hitting anything, when this is false, we don't want anything to happen. It's only when something does get hit that we want to do true. And we get a sequence, and the first thing we do in the first sequence is we only do once, we spawn our actor. We don't want this, if we don't do this do once, say we plug this directly in, we're going to have a lot of these markers being spawned. Now see, that's not something we want, and this can affect your frames per second. So if I start doing it, the frames per second is dropping a lot. And that's why we want to do just this do once. And we reset this do once the actual mouse button, the right mouse button down, is false whenever we lift up from that mouse button. That's when we want it to reset this. And then from the second sequence, that's when we set up our function that basically sets offsets for each direction, the X, Y, and Z, so that there's no clipping because it's a plane we're dealing with. And it has two inputs. It has an impact point that we get from the break result of our trace. We plug that in. And it also has an up vector, which we get from the impact normal, and we make the rotation from the Z, and then we get the up vector from that rotation and set it to the up vector. And then the output vector is the location offset. So this gets plugged into both the spawn transform location for our spawn actor from class function, and it also goes into our new transform location. And because this second sequence is being hit each tick, that's why it gets updated so well. And then for the rotation, we just get the make rotation from Z from this impact normal. We get that rotation, and we set it to the spawn transform rotation in our spawn actor from class, and we also set it to the rotation for our set world transform. And the set world transform is only setting the SN marker, but like what we did earlier for the marker, we set the domes here, the small and large domes. We set it as children of the marker. So any rotation or location updates made to this marker will also be made to these domes. And that's why they both update. So again, just to show you the end result, you see the two domes, we see the large marker, and everything's working as expected. Obviously, there's more to build upon on this. I'm still working on future iterations to make sure the ground pound actually works. Right now, this is just the marker itself, so just keep an eye out for future blueprint examples, future live streams, and future tutorials about this. But for now, this is the end of this tutorial. If you like the content, make sure you subscribe if you aren't subscribed yet to the Devin Level Design YouTube channel. Make sure you like the video, have comments, let me know your thoughts. I know some people have been telling me that they can't see what's on screen. I don't know what to do about that. I'm using XSplit, and that's just how it captures everything. So that's why I try to talk through it. So if you can't follow along, I'm sorry. But no, there's not much I can do about that except talk your way through it. But also, make sure you share the video too if you thought this was useful information. But for now, I'll see you on the next tutorial. I'll see you on the next video. But thanks for watching.